All right, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy. Today we'll be talking about subtracting integers. So what I want us to do is start out with using a model, something that you would normally have as a manipulative that you can touch, but try to follow with me as we understand what it looks like to subtract integers. So this is a type of model that we'll look at using counting counters as we talk through them. So it should make sense as we walk through it here. Let me get my pencil out and ask these questions. How can subtraction be modeled using counters? What is subtraction property? And what happens when we subtract a negative? So those are the questions I want to answer during our time today. As children, we understand subtraction through real life experiences like having 5 cookies and somebody took away 3. So we could get that math down pretty quickly. So you got your 5 cookies, someone comes and takes 3 away, and you quickly can figure out how subtraction works because now you only have 2 cookies left. But it's not always so simple. But I want to use some tiles to try to help understand this. So what I'm going to do is model 4 different subtraction facts using those numbers 5 and 3. So starting out with the model of 5 minus 3. Pretty simple. We just shown that with cookies, but I want to introduce you to the counters as we go through this. So we have 5 counters. I put plus signs on them so you'll know that they represent a plus 1 value for each one of them. And if I were to take away 3, that will make sense, right? So I got 5 minus 3. That simply means I'm going to take away 3 of these pieces. Well, taking away 3 of those pieces is not hard to understand because when I take away 3, 3 goes away. Bam. And I have 2 left over. Not difficult. So let's use another one. What about negative 5 minus negative 3? What would that look like? So I have a negative 5. This time I want to take away negative 3. So I have negative 5 and I want to take away negative 3. So take away negative 3 of these. Negative 1, negative 2, negative 3. I could take away negative 3. It's pretty simple. Instead of taking away positive, we want to take away negative 3 of them. And if we do that, again, we'll see quickly that we're left with 2. So that'll give us an answer of negative 2. Now, this problem without these counters may have looked a little bit confusing if you thought about it just with these signs and numbers. But if you can put the counters up here just to give us a basic idea of how to start, you can see that we started with negative 5 and we took away negative 3 of them. So we just decided to take away these negative 3s. 1, 2, negative 3. If we were to take away negative 4, then we would have had 1 negative left. So taking away these negative 3, our answer should be negative 2. All right, this time let's do it again. Let's do negative 5 minus 3. Negative 5, take away 3. 3 positives. Well, there's a problem here because though I have negative 5 in front of me, how can I take away 3? I have negative 3, but I don't have positive 3. So in order to overcome this challenge, I'm going to actually need to add 3 positives and add 3 negatives. Remember that by adding 3 and subtracting 3, we still have 0 pairs. So we haven't changed the problem at all. But now when I relook at the question, it will allow me to accomplish what I'm after. So negative 5 is what I started with. And I'm going to take away 3 positives. So those 3 positives are right here. And when I take those away, they're gone. And now I can see what my answer is. So I had negative 5, I took away 3. Now I have 1, 2, 3, 4, 5, 6, 7, 8. So negative 8. I feel like I need to do that again one more time because that is a little crazy to think of it this way because it's not a simple 5 cookies minus 3. I have negative 5 and I'm taking away 3, but the problem I don't have 3. And by 3 is a positive 3. So I don't have a positive 3 to take away. So I need to add those 3. But that would change the problem to something different by adding 3. So I'm going to also add negative 3. This way I have 0 pairs that these all add up to 0. So really I haven't changed the problem. Now I can take away 3 and that gives me my answer. All right, the last one, I told you I'll show you 4 different ways, is 5 minus negative 3. So what I'm going to start with? 5 positive counters. So I'm going to start with 5 positive counters. Then what? Take away negative 3. Well, I don't have any negative 3s to take. I don't have any negatives to take away. So yes, I'm going to have to add those negative 3s in here so that I can at least take them away. But I can't just add negative 3. I need to put the 0 pairs that go with them so I don't change the problem. So these are just equal to 0. Nothing's changed. Now I can do 5, take away negative 3. I can take away these negative 3s, and that leaves me, when I do that, these 8 in front of me. So 5 minus a negative 3 equals a positive 8. Isn't that crazy? That sounds weird. But showing you in the counters hopefully gives you the idea of how that works. That's one way we can see how it works. So subtraction without counters. Now, what if I took away the counters, right? Because the whole idea of having counters is to allow you to get the idea of what's going on. So let's think through this problem. Negative 23 minus 7. What's the answer to that? How would you think about that with counters? Well, if I thought about that with counters, I would think, well, we start with 23 negative counters. So I got these negative 23 counters in my head that's on my screen. And then I take away 7 of them. Well, I just get rid of 7 of them. We have to subtract 7. I'm sorry, not 7 of the negatives. We have to subtract 7 positives. So take away 7. But we don't have any positives. So we're going to have to add 7 neutral pairs, which means 7 positives and 7 negatives. Then I could take away those 7 positives. So we have the original 23 plus 7 more negatives and a neutral pair. So now the result is 30 negatives. So that I had to add those negative 7. I took away those positives, and I have negative 30 as my answer. So the answer is negative 23 minus 7 is negative 30. Let's do one more, because I know that's kind of hard to follow without the pictures, but I'm just trying to push your mind a little bit to think about how it would work. Now, in just a second, I'm going to show you the rules for how to work through these quickly, but this will be the only time where we take the time to lay the foundation of what this actually looks like behind the scenes and why it works the way it does. So notice that we subtract 7, we added those 7 negatives. So that's really what we're doing. So let's do it again. So what if we have this problem? Subtract 30 minus a negative 12. So we got a positive 30. That means we got these 30 blue circles on our screen. And we're taking away negative 12. Well, how can we take away negatives when all we have is 30 positive circles on our screen? In our minds, right? Because I'm not putting them on the screen. So I kind of want you to just think about this. How's that going to work? So 30 take away negative 12. Since I don't have any negatives, I'm going to have to add 12 negative neutral pairs. 12 neutral pairs, which means 12 negatives and 12 positives. Remember, adding 12 negatives and 12 positives keeps the answer 0. So in essence, we've not changed the problem at all. We're just doing that so we can accomplish the task of taking away negative 12 units. So we're going to say start with 30 positives. We have to subtract 12 negatives, but there's no negatives. So we add 12 neutral pairs to those 30. And now we can take away those 12 negatives. And what's left? We have the 30 original plus 12 more positives because of those neutral pairs that's still left over. The result is 42 positives. So 30 minus negative 12 is 42. Notice that to subtract negative 12, we really just added 12. So we're going to look at some rules to kind of help simplify this. One of those rules is this. We'll learn that a minus b is the same thing as saying a plus negative b. And here's how it looks. So 6 minus 4, so you have these 6 blue ones. Take away 4 is 2. And 6 plus negative 4, so I got 6 add negative 4. Well, these all end up going to 0 as 0 pairs or neutral pairs. So that's gone, and I have 2 left over. So no matter what, a lot of students even prefer to do this. Anytime they see a subtraction, they will put an addition sign in front of it to remind them that you're just adding. You're just adding some negatives. And if that helps for you, you may want to do that too. All right, so let's simplify these, remembering that these are actually the same thing. So 13 minus 8 and 13 plus a negative 8 are really the same thing. We're saying 13 minus 8, and 13 minus 8 is just 5. Now, I'm not going to draw the counters out because you can get the idea. You got 13 counters and you take away 8. 13 plus a negative 8 is going to give you the same thing. 10, 11, 12, 13. Negative 17 minus 9 is the same thing as negative 17 plus a negative 9. So negative 17, adding another negative, more negatives, is going to make this even more negative. So it'll be negative 26. So know that those are exactly the same. All right, what happens when we subtract a negative? So we saw this a second ago in our problem that we just did. So what's really happening? So we have 8 right here minus a negative 5. Take away a negative 5. 1, 2, 3, 4, 5, 6, 7, 8. We got 8. Well, we don't have any negatives to take away, so we added negative 5 and plus added 5 positives and 5 negatives so that we could take these away, and it gave us 13. That's the same thing as saying 8 plus 5 because we could have just added these on the top, these positive ones. So there's a cool rule to remember. If you have a negative and a negative or minus a negative, this is just going to become a positive. Very important and powerful rule that will uncomplicate many matters concerning adding and subtracting integers. So let's do some practice problems with those so we can see what that looks like in practice. So here we go again. We have 9 minus a negative. Really, I always say just make that a positive because in essence, it's like you're saying negative times a negative, which is a positive, which we're going to talk about later. But we know that this minus and this negative are going to go into being a positive as we see here. So 9 plus 15 gives us 24. Is that right? Yeah, 24. And negative 7 minus a negative. See, these connecting, don't try to connect this negative here, but these right next to each other is going to be the same thing as plus. So negative 7 plus 4. The negative is bigger on the 7, so I know it's going to be a negative. Answer 7 minus 4 is 3, so it's going to be a negative 3. I think I skipped one. Yeah, this is really important right here. All right, so here's a summary of what we just talked about. 5 minus 3. Let me get my pen out. 5 minus 3 is 2. Negative 5 minus a negative 3 is negative 2. If you got two positives, when there will be enough counters on the color to take away, we're going to just subtract. So if there's enough things to take away, we got 5 that we can take away only 3, we're just going to subtract. So we got negative 5, we're going to take away negative 3, we're just going to take those away, we're going to subtract. So we're just going to take 3 away, we're going to subtract those. So we can do that. However, you got negative 5 minus 3, 5 negatives, want to subtract 3 positives. We don't have any positives, we need neutral pairs, and this is where we have to remember that this is going to end up being a negative 8. These two ends up turning into a plus, so that's 5 plus 8. So when there would not be enough counters to take away, we add neutral pairs. Now, don't be discouraged if you don't completely get the counters, because that's trying to help you understand the behind the scenes what's going on. What you do need to remember is a lot of these rules, and well, I won't say a lot of rules because I don't want you to try to fixate on the rules, but this is such an important one to remember. This negative and negative together becoming a positive. And when you have a negative and you take away more, you're going to become more negative at negative 8. So just having that understanding is very important. Let's do some more. So as soon as I saw this problem, what did you notice? Look at this, minus a negative. So I'm going to go ahead and just rewrite that. I won't even bother looking at anything else before I change that, because those two together just starts to, it's just hard to think about working at until you give it one sign. So negative 74 plus 58, you can already realize that this is going to be a negative or positive number. Which one? I'm hoping you're saying negative, because negative is the bigger number. So whatever my answer I get when I subtract these two, so let's subtract it. Let's just say 74 minus 58. Whatever answer I get, I know it's going to be negative because that's my bigger number. So this should be a 6, 14, that's a 6, 1. So it looks like my answer should be a negative 16. All right, another one similar to it. I want to put these together right here, but before I do, PEMDAS tells me to do parentheses first. So I'm going to go 7 minus, and I'm just going to put it, I'm going to work the parentheses first. Negative 4 minus 3 is going to be a negative 7 minus 9. Why? Because even if I use the number line where this is 0, this is negative 4, this should be a 0. And I took away 3 more. That means I got to go back. 1, 2, 3. It's going to take me to a negative 7. Or if you want to think about it in counters, negative 4, 1, 2, 3, 4. These are my counters. And I subtracted 3. I don't have 3, so I have to add 3. And then I have to add the neutral pair, 3. And then I can actually get busy doing the work of negative 4 taking away 3. So these are counters right here. So if I took these 3 finally away, now I have 7 negatives there. Just wanted to reinforce that if you were still struggling. Why did I erase all that? I actually wanted that. So let's keep it moving. We're going to now look at this piece here. We got minus a negative. I'm going to go ahead and change that to a what? You got it. A positive. All right, now PEMDAS tells me that I can just go left to right because they're both addition and subtraction. So 7 plus 7 is 14. 14 minus 9 is 5. That equals 5. Done. Having fun. And done. All right, so this is a doozer. Look at all that stuff there. So PEMDAS I'm going to write here because it looks like there's a lot of operations and we don't want to mess that up. So let me talk us through. Let's talk through the operations. So if it helps for a lot of us, you should mark the operations, all the operations that's happening, maybe at the top, and you can kind of think through which goes first. Now, do I have any parentheses? Nope. Do I have any exponents? Nope, so I don't have to worry about that. Now, going from left to right, do I have any multiplication and division that pops up first? Yeah, I do got to multiply. So I'm going to do that first. Subtraction, that comes after multiplication and division. So I'm going to do this multiplication and I'm going to do this first. So this may help some of us with struggling with all this work, all these numbers and operations. Let's simplify. Let's do the ones we circled first. 3 times 7 is 21. I'm just going to rewrite my minus. 4 times 7 is 28. And I'm going to rewrite my minus sign. And then 5 times 8 is 40. All right, now I don't have any more, I only have minus left. So that's easy because that's addition and subtraction. That's the only one I need to continue working on. So now I'm going to just do that in order. 21, take away 28. Let's start with that before we get to the 40. What's 21 and you take away 28? So what's the sign of the answer? Is it going to be positive or negative? Well, in this case, we have a positive 21, and we're taking 28 away. So 21 minus 28 is the same thing as 21 plus a negative 28, if you remember that. So we actually have a negative number that's bigger. So I know my answer is going to be negative something. Well, 28 minus 21 is 7, so I know it's going to be a negative 7. Now I need my last piece here is minus 40. So remember that negative 7 plus negative 40. So these are both negative. I'm just adding more negative to it, so it's going to be a negative 47. There we go. And let's do some evaluating. So what if we plugged in some values here? So for x minus 4, we put it 3. That'll give us 3 minus 4. With 3 take away 4. If it helps you, that's also the same thing as 3 plus a negative 4. I know my negative is bigger here, and that's going to give me not 1, but negative 1. Negative 6 minus 4. If I put it into this expression here, that's the same thing as negative 6 plus negative 4. So I lost $6 and lost another $4. I lost $10. I lost negative $10. So that's how you work that one. And let's evaluate this. What if z was 12 and negative 12? So if z is 12, this is going to be written as 20 minus 12. Oh, that's pretty easy. That's just going to be 8. But what if it's 20 minus z? So this is our z. I like to put a line through it so you know z. But this time it's 20 minus whatever z is. So this is going to be a negative 12. And be careful here because you got to keep this minus sign here and then let z be your negative 12. And I know when I have this minus and negative right next to each other, it turns into a what? Yes, yes, yes. A plus sign. So that should become a pretty easy problem. So now we end up with 32. All right, did we accomplish what we said after? Absolutely. How can the addition of integers be modeled using counters? We did that. Even though it looked kind of crazy at first, we figured that out. How can expressions with integers be simplified and evaluated? We worked through some practice problems showing how you can simplify some expressions and even evaluate some of those expressions when you plug in a value, like we did, 12 and negative 12. Thank you for tuning in. Again, my name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.